back, friends. Welcome to the second set of the series of biochemical calculation videos. And in this video we are going to talk about how to convert molarity into molality and then molality into molarity. So for this understanding of calculations, you need to know about what is molarity and what is molality. If you are watching the series of videos, you probably know what molarity is. But let me tell you the difference between molarity and molality. You know, there's three terms you need to know. One is this mole, right? The mole of the molecule that is out there. This is one you need to know. And the other thing that you need to know is molarity and molality. Mole is calculated based on the total amount of the atom or ion that is involved. Okay. So you can say, for example, sodium chloride. 1 mole of sodium chloride equals to approximately 58 grams of sodium chloride. So it's also an entity, it's an amount based on the calculation of the number of atoms in there, or stuff like that. Okay. While molarity is represented by this mole divided by liters. Mole by liters. That's how we calculate molarity. And we represent it as capital M. While molality represents as mole, let me write small m, mole divided by the kilogram of solvent, represented as small m. So that's how we'll convert. So going from molarity to molality is from capital M to small m, and the other one from small m towards capital M. So in this first video, this is the first question that we'll solve. We are actually going to convert from, calculate molarity of 4 molar solution of glycerine with a density of 2 gram per cubic centimeter. So in this case, we want to produce and we want to find molarity from the molality. Molality is given, small m is given. We need to find out the capital M. So this is what we are solving right now. So we are given mole per kilogram of the solvent. That is molality that was given. Okay. We need to find out the molarity, which is capital M, which is calculated by mole per liter of the solution. Remember. Okay. So to answer this type of questions, this is nothing but unit conversion. All this question, they're nothing but unit conversion. And we solve this question with an idea known as dimensional analysis. If you don't have any idea regarding dimensional analysis, I want you to watch the previous video of this series where I discussed about the dimensional analysis in details. So in this case also, first thing we need to understand few things. 4 molar solution of glycerin is provided, and you know 4 molar solution means what is the total mole of glycerin that is present? 4. So it's already provided that 4 mole glycerin is present. So the value of mole, so you know we need to calculate molarity. So let me write molarity equals to this mole divided by the liter. So the mole is provided 4. So we only need liters of the total solution, the total volume of the solution, which is not mentioned in this question. Instead of mentioning the volumes, they have mentioned gram per cubic centimeter, which is the density of the solution. So now we need to calculate the volume of the solution from the density, because once we find out the volume of the solution from the density, we can simply put the value and we'll get the molarity of the solution. So this is what we need to find out first, that to convert this density into the total amount, total volume of the solution. So remember one thing, to solve that, you know, they provided us 4 molar solutions. So molality, and you know molality equals to the mole of, in this case, glycerine divided by kilograms of solvent, which is water. But in calculation of molarity, we need the volume of the whole solution. In this case, the idea of 4 molar glycerine contains only the kilogram of water in it. So we need to calculate the volume of water which is present, and then we need to also know the volume of the total solution by adding the total amount of glycerin is present, and then add them together to find out the actual volume of the solution. Remember that this is the biggest difficulty of this question in here. Okay, so how to get this idea? So first of all, we can say 4 molar solution. So 4 molar solution, you can simply say that the 4 molar solution. So to answer this 4 molar solution, 4 molar means how many gram of glycerine? We don't know, because the idea given here, the density given here is gram per cubic centimeter. So if we can calculate the glycerine in grams, the amount of glycerine in grams, we can simply find out the volume of glycerine. How to do that? So the easy way to find out the amount of glycerine in grams is simply to look for the C3H8O3. That's the formula of glycerine. So what we can say, carbon, each carbon 12 into 3, because 3 carbons are there, plus hydrogen is 1 into 8, plus oxygen is 16 into 3. So it gives us all total of 92 grams. So we call it 92 grams per mole. 92 grams per mole is the amount of glycerine that is present in here. So 92 grams per mole amount of glycerine is out there, and we know 4 molar. So for 1 mole it is 92 grams. So for 4 molar it will be 92 into 4, 368 grams. So it will be 368 grams. So that is the total amount of glycerine that is present in there. So now, as we know the total amount of glycerine that is present in there, we also need to know the total amount of water that is present in there. The total amount of water we need to assume, because it's not clearly mentioned in here, and if the total amount of water is not mentioned earlier, you always think of it as a 1000 milliliters or 1 liter, because we need to do the calculations in molarity, so you'll always convert it into the liter. So let's assume the water present here is also of 1000 gram. So water 1000 gram, glycerine 368 grams. So total amount is 1368 gram. This is the total amount of the solution that we got, 1368 gram. Okay. So now once we find out 1368 gram solution, okay, now we need to convert this into volume, because that's what we get in amount. We need to convert it into the volume, including the idea of density. And conversion of this gram or amount into volume in liters, we need to use dimensional analysis. And what is that? Let's say here 1368 gram of solution we have there, okay, into what we can write in this particular place. It's simply 2 gram per cubic centimeter. So we can write 1 cubic centimeter contains 2 gram of this glycerine. That's how we can write it. 1 cubic centimeter contains 2 gram of this glycerine. Okay. And ultimately, what else we can write? Because all these equations now continue with cubic centimeter, and 1 cubic centimeter is equal to 1000 milliliters. So what else we can write? 1 liter equals to 1000 milliliters. And if you recall the idea of dimensional analysis, what was the idea? Idea is you need to put the equations in a way so that the same units cancel each other out. For example, 1 cubic centimeter equals to 1000 milliliters. So the same thing, the milliliter and cubic centimeters, they will cancel this. This cubic centimeter will cancel this milliliter out in both this case. And on the other hand, the gram solution will cancel the gram solution here also. The gram of the total with the gram of this. So they will also cancel each other out. So ultimately we'll end up in what? The only unit left is liters. So we are going to get the value or the volume in liters. How? 1368 divided by 2000. That much liters. That's what we've got. So you can simply solve this, like, let's say if we write it like 2 into 1000, then we can say 684 divided by 1000. So 0.684. 0.684, that's what we are going to get, So 0.684 liters is the total volume of the solution. And I told you earlier that to calculate molarity we need two things: the mole of the solvent here, the mole of the solute here, that is the glycerin, given 4, and the volume in liters. So now we already calculated the volume in liters. Plunge this value here, 0.684, and we already knew the moles. So 4 moles divided by 0.684 is going to give us the molarity of this solution. And how to calculate the molarity? Actually, although in CSIR UGC NET exam they are not going to give you calculations that you need to do without, because without calculator. In this case I am using calculator to calculate that. So 4 divided by 0.684 gives us 5.84 mole. 5.84 mole. Molar, sorry, not mole, because there is a difference between mole and molar. Mole is always in terms of that small part, small m, and capital M is the mole by liter. That's why molar is different than mole. So you can see 5.84 molar is the molarity of, or 5.84 capital M is the molarity of this solution. So that's how you need to solve, and you need to convert molality into molarity. So this thing might be a little difficult for you. I want you to repeatedly watch this video several times to get this concept clear in your mind, because a lot of things are going on in this concept. First of all, understanding the difference between molality and molarity, and also to understand the interconversion idea with this analysis method. Okay, so now let's look at the second part of this video. In the last part of this class, we've talked about the conversion from molality to molarity, small m to capital M. And this part will be converting the capital M into small m, or molarity into molality. So the question is, calculate the molality of 2 molar solution of glycerin with a density of 3 gram per cubic centimeters. So again, like always, we now need to calculate small m, or molality. So molality equals to the moles divided by the mole of, in this case, the glycerin divided by the kilogram of water that is present. But in molarity, it's all about the mole of the glycerin divided by the liter of the solution. And the solution means we have glycerin plus water both together counted. So here the molarity of the solution is given 2 molar, but in this 2 molar value they have already included the presence of glycerin as well as water. But when we calculate the molality, we don't need the volume of glycerin, we only need the volume of water to calculate it, the amount of water to calculate it. So this is the biggest challenge of this conversion from molarity to molality, is to exclude the solute, the amount of solute out from the total solution. That's what is very, very important and unique that we need to perform. So let's look at here. Mole of glycerin is already told 2. So if we need to just find out the kilogram of water that is utilized, and to find out the kilogram of water utilized, what we can say, the kilogram of water utilized will be equals to the kilogram of solution, the total solution utilized, minus the kilogram of glycerin that is utilized, because the total solution minus the glycerin will be equals to the kilogram of water that is left. So we need to find out the kilogram of solution, which is not known in here, because instead of providing the amount of solution used, they are given density of the solution to make things little complicated. So again, we need to convert this density into kilogram of solution. And how to do that? To answer that, let's look at here. To convert this density into the kilogram of solution, we need to use again the dimensional analysis. So again, this dimensional analysis will rescue us to solve this question. How? Let's assume in this question, whenever they don't tell you about the total amount of the solution, you always assume it like 1000 milliliters or 1 liter, because 1 liter is always involved in molarity calculations. In this case, we'll always assume the solution is of 1 liter total. So what we can write, 1 liter of the solution, remember, equals to, so simply 1 liter of the solution, so simply convert the liter into milliliters in here, so you can write it like 1000 milliliters of the solution divided by 1 liter of the solution. The same thing, so you are converting liter into milliliters, so simply write it as 1 liter equals to 1000 milliliter. That's how we represent the conversion of units with this type of analysis. And then the dimensional analysis, and then we have milliliters and we also have liters in here. So what else we need to do? We need to go for this 3 gram per cubic centimeter, which is really important here, 3 gram per cubic centimeters. So 3 gram, so let me write it as 3 gram per cubic, so 1 cubic centimeter. That is the density. So this was the volume and this was the density. So now remember, cubic centimeter and milliliters are the same units. So we know that these things will cancel each other out, and that's the actual fundamental concept of dimensional analysis, that the units will cancel each other out. And the last part is what? In this case, simply that we know this 2 molar solution is out there, and what is the amount of glycerin, because you know in this case it's not about the water only, it's about to find out the kilogram of solution utilized. That's what we are finding out, and we assume that the whole solution was of 1 liter or 1000 milliliters. That's what we begin with in the first place. So kilogram of solution contains, this is only about the dimensions, so density of glycerin. So we also need to understand the total amount of glycerin, and how we will get the total amount of glycerin. So now, as we know the conversion of milliliters, and we also put the density in there, but what we need to figure out is kilogram of solution. To find out the kilogram of solution, because you know we don't need to know the glycerin separately in this case or water separately, we just need to know the overall solution, which we assume of 1 liter. But we need to convert it into kilogram, because all the units now, as you know, the milliliters and cubic centimeter will cancel each other out, so we left up with grams as the unit, but we need it in kilogram. We simply write it as what? 1 kilogram equals to 1000 gram. By putting 1000 gram to the bottom, we know gram will cancel each other out in both the sides, so we only left up with kilograms as the unit. So find out the answer at this point. It's simply as easy, 1000 will cancel also each other out in both the sides, so it will be 3 kilograms of solution. So now we know the solution, kilogram of solution is 3 minus the kilogram of glycerin. So we need to now find out the kilogram of glycerin that is utilized. The same way we find out here, we are going to figure out the kilogram of glycerin utilized, right? So how exactly we'll find out the kilogram of glycerin? To find out the kilogram of glycerin, we'll start with the total amount of glycerin utilized, that is 2 molar glycerin utilized, and we are going to do another round of calculation. So let me take my eraser here, and I'm going to delete this part. Okay, so let me do another round of dimensional analysis in here. So we can write it as like, you know, 2 molar. So we can simply write it as 2 mole of glycerin, right? Because in 2 molar glycerin we have 2 mole and the total liter divided by the liter. So 2 mole of the glycerin. Now what we can write in here? It's simply glycerin, if you imagine, glycerin equals to 92 grams per mole. That is the total weight of the glycerin, 92 gram per mole. Why? Because in glycerin formula is C3H8O3. So 3 carbon each is 12 into 3, 8 hydrogen, so each hydrogen 1 into 8, and oxygen 3 oxygen, each oxygen 16 into 3. So total 92 grams per mole. So we'll write it as, in this case, 92 grams per mole of glycerin. That's how we can write it, 92 grams per mole of glycerin, right? Now the last part of this equation, because you also need to calculate the amount of glycerin in kilograms, and now we know the gram per mole, the mole glycerin will cancel each other out in both the sides, giving us a gram as a unit, but we need to convert the gram into kilogram. So what we can write? What? 1 kilogram equals to 1000 gram, and gram will cancel each other out, giving us the value, the amount of glycerin in kilogram, and that will be what? 92 divided by, so you can say 92 into 2 divided by 1000. You can write it like 184 divided by 1000, or 0.184, right? That's what you can find out. 0.184. So once you find out 0.184, this will be the kg of glycerine. So now we got both the data. We got the data of kg of solution 3, we put it in here, and we also kg of glycerine, that is 0.184, giving us the kilogram of water. Because this is the most difficult part, remember I told you in the first place. So what will be the answer in here? 3 minus 0.184, 0.184 gives us 2.816. So 2.816 kilogram of water. And remember now the actual formula, molality equals to mole of glycerine by kilograms of water. The mole of glycerine is 2 mole, which is already provided earlier, and the kilogram of water we just calculated 2.816. So what is going to be the answer? 0.716. This is going to be the answer in our case. Kilogram of water 2.816 in here. So yeah, 0.716 molality. So this is going to be the molality for this solution. Remember one thing, if they ask you question regarding conversion of molarity into molality in CSIR UGC or GATE, they are going to ask you questions which you can calculate without the calculators if it's not allowed. If calculator is allowed, then definitely they will ask you question related to the decimal point. And this is the way to answer all these questions. And we've seen two types of conversion, molality to molarity, molarity to molality. But you see, in this second part, the biggest problem in here to answer this type of question is simply to find out the kilogram of water that is utilized. Okay. On the other hand, in the other examples earlier, we already saw that is sequential approach and step-by-step process for calculating molarity as well as molality. Okay. So if you like this video, please hit the like button, share this video with your friends, and subscribe to my channel to get more and more biochemical calculation videos like that. Okay, and stay tuned and watch the whole series, because the next video we are going to talk about the amino acid problems, especially the problems associated with the amino acid charge with changing pH and pKa values, and also we'll talk about the pi values of amino acids and why they are so much important. Thank you. So if you like this video, please hit the like button, share this video with your friends, and subscribe to my channel to get more and more self-help education videos like that. And obviously share this video as much as you can to the social networks so that other people know about the exam before taking it.